In this problem, we're looking at some numbers that are reasonably ordinary for a lightning strike. I think this lightning strike is perhaps a bit more aggressive than average, but it's plausible. So we're given that 10 to the 20th electrons are transferred, and it takes 30 microseconds to get this done. And the average potential difference they're accelerated through is 50 million volts. So in part A, we want the average current during the strike. So we just find the charge that was transferred, and then we divide by how long it took to find the charge that was transferred. And I'm just going to speak in magnitudes here, so forget the minus sign for now. I have 10 to the 20th electrons, and then a charge magnitude of 1.6 times 10 to the negative 19 coulombs for every electron. So this comes out to a nice round number, 16 coulombs of charge transferred in the lightning strike. So then to get the average current, I just take how much charge was transferred and divide by the amount of time it took. So 16 coulombs was transferred in 30 microseconds. That's 30 times 10 to the negative 6 seconds. And coulombs per second are amps. So when I do the math on this, I get 533,000 amps, which I'm going to call 533 kiloamps. Next, I want the average power delivered by the strike. And so I'm just going to use my fundamental power formula, P equals IV. And if we're talking about the average current and an average voltage that the current was moving between, then we'll get the average power. Again, we were told in the setup to the problem, the average potential difference during the strike is 50 million volts. As the discharge is occurring, you would expect the potential difference to decrease. And that's why I had to use the word average. So our average current was 533 kiloamps, and then our average potential difference, 50 megavolts or 50 million, or 50 times 10 to the 6 volts. And I end up with a number of 2.67 times 10 to the 13 watts for the average power. And this should be expressed in a more appropriate unit. So 10 to the 9th is giga, 10 to the 12th is tera. So if I write it as 26.7 times 10 to the 12th, I could say this is 26.7 terawatts. If you find the physics content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce over 100 new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.